So here we're going to begin looking at causation and the use of experimental research. So many times in research, we're asking the question, what causes blank? So for example, according to the National Crime Victimization Survey, violent crime has been declining since the 1990s. So we might ask the question, what caused the decrease in violent crime? Could it be that because of computer programs that identify where crimes are clustered? Is it because of programs like Safe Streets, Safe Cities, which increase the ranks of police officers? Does it have something to do with drug use? Is it because drug use has been on the decline? Or are people just changing? Are people becoming less violent in general? As another example, obesity has been increasing in the United States for over 100 years, but there was a sudden sharp increase in the 80s and 90s. So what caused that sudden sharp increase? Is it because kids are watching too much television and playing video games instead of playing outside? Is it because schools have reduced or eliminated physical education? Could it be that adults have more static work positions? They sit at a computer all day. Or is it because people eat in restaurants more often instead of cooking healthy meals at home? What we're really looking at in both of those examples are we're looking for causal explanations. A cause is an explanation for some characteristic, attitude, or behavior of a group, individual, or for events. So for example, we might say drinking alcohol causes hangovers. So you can only establish causation when you can say that a change in one variable will cause a change in another variable when all other things are equal. And this requires researchers to isolate a variable. So imagine you wanted to see if coffee causes your teeth to turn yellow. You would have to isolate coffee as your independent variable. You'd have to find two groups that do everything the same. They brush their teeth with the same toothpaste, they visit the dentist with the same frequency, they eat the same foods, they chew the same gum. Everything's the same except for the variable coffee. The only difference between the groups would be that one group drinks coffee and the other one does not drink coffee. And that is the only way we can know if the difference in teeth color has something to do with coffee. Because if the groups vary in other ways, we won't know what caused the yellow. Some people try to claim causations when a series of events or actions results in a particular outcome. So here's an example I read from the book. So maybe an individual is neglected by his parents. He comes to distrust others. He has trouble maintaining friendships. Then he has trouble in school and he eventually gets addicted to heroin. To support his habit, he starts selling drugs and is ultimately arrested and convicted for drug trafficking. We cannot say that parental neglect causes a person to get arrested, but we can identify a chain that may have led there that could start with parental neglect and end with getting arrested. But there are many things in between. There are a lot of variables involved. That is not a causal relationship. There, in fact, is very specific criteria to determine if there is a causal relationship, and it's very strict. So first, there must be experimental association. So you'll find a relationship between the variables. And if that alone is all you have, we might call that correlation, which we've already learned about. But this is more than correlation because of the way the study is designed, and we're going to get to that in a few slides. Another thing that's important for establishing causation is time order. You need to be able to say which variable came first. Did X cause Y or did Y cause X? For example, maybe you found that people who play violent video games demonstrate more violence, But how do you know which came first? Is it possible that people play video games and that causes them to be more violent? Or is it possible that people who are already predisposed to violence choose to play more violent video games? We need time order there. And then finally, I already said this, but I will probably keep saying it, which is it is very important to have isolation of variables. Researchers must be able to demonstrate that an association between two variables is not due to a variation in some other third, fourth, or fifth variable, like that example we gave with the parental neglect, that association between parental neglect and arrest rates might be because of many other variables that are stuck in between. We need to be able to say that the association is cleanly between two variables and nothing else is getting murky in there. So for example, we might say tall people live in bigger houses. Does great height cause a person to buy a bigger home? What other factors could be at play? So is it possible that tall people buy bigger houses because they need more space? Or is it that tall people exude power and that gives them more leverage in the workplace and they're more likely to get raises, they're more likely to make more money, and therefore they're able to afford bigger homes? We don't know based on the association alone. We need more information. So here we're going to break down a very specific type of research, experimental research. And after this lecture, we'll get into non-experimental research, but this particular segment is about experiments. And this is when the focus is on the identification of a cause. You may remember we spent a lot of time talking about types of research questions. Well, when our question is, does blank cause blank, then we know we're looking to do experimental research. So maybe we find, our hypothesis is that supervisor neglect causes poor performance in the workplace. This is our hypothesis. We can best answer this question by manipulating the conditions that one believes are responsible for that effect. So, for example, we might randomly assign employees to one of three conditions. So you take a group of employees and randomly decide some of them are going to get a high level of supervisor attention, some of them are going to get a low level of supervisor attention, and the third group have no explicit instructions are given. So maybe we have a sample of 60 employees, 20 of them go to the high level of supervision, 20 of them go to the moderate or low level of supervision, and 20 of them receive no supervision. They get no instructions from a supervisor. And then at the end of that, we measure their performance. The key thing here is this red box. The red box around the orange boxes. All other conditions must be the same except for this one difference. So you see it in the brown box at the top, we have 60 people. We're going to divide them and change just one thing about each group. Everything else about the group has to be the same. They all need to come to work at the same time. They all need to have the same level of responsibilities, etc. The only difference is how much supervision they get. And the reason for that is when we get to the yellow boxes at the bottom and we're measuring their performance, we want to be able to say that any differences that exist between these three groups was directly related to their supervision level. And we don't want to have to wonder, was it something else that caused this difference in their performance? We want to be sure that the thing that caused the difference in their performance was their level of supervision. So experimental research is rigorous. It is very strict. There are a lot of rules, and it's the only kind of research that can make true claims of causation. Sometimes you will read in the media descriptions of studies that took place where media will kind of warp what happened, and they will write about, X causes Y, eating artificial sweeteners will cause you to gain weight is one that I saw recently. And those claims are false, that they didn't come from experimental research. And so we can't really say one causes the other. And so after this class, I'm hoping that as you are reading newspapers and magazines and website articles, that you're questioning, they're saying that this causes this, but do they really know that from experimental research? So I'm just going to quickly take you through a couple of research designs. So the first one is called a two-group post-test comparison. And this is where you have an experimental group and a control group. The experimental group gets an intervention, the control group does not, and we just measure at the end who's different. So imagine you have a study in which you enroll 100 police officers, 50 of them go into your experimental group, 50 of them go into your control group, and you see in red a note that will happen randomly. You don't pick and choose who goes where. You randomly assign them to either the experimental group or the control group. You provide the experimental group with 20 hours of special training, that's the intervention, and the training is in driving motorcycles, and then you measure how well each group drives the motorcycle at the end, that's the post-test. You'd assume that the intervention group would drive better, that's our hypothesis. And so we would then do the study and find out. So an advantage of this type of study is that you have randomization, and so you do not allow police officers to choose their group. And for that reason, we can say that there's a little less bias in this study than there would have been otherwise, because if police officers had chosen their own group, if they've said, I want the training or I don't want the training, you might find, for example, those who chose to go through the training were those who were already really confident in their skills, and they just like going to trainings. They've been to trainings before. They're already very knowledgeable about motorcycle riding. Or you might find that those who chose the training were those who were really insecure about their driving skills and thought, I could really benefit from this. Either way, it doesn't really matter how it all pans out. Either way, you're introducing bias. So in this case, we did not allow that to happen. One of the major disadvantages of this type of research design is that there is no pretest. So we don't know if, maybe all of the officers who were placed in the control group all owned motorcycles at home and they already drive them on a regular basis. Yes, we eliminated some of the possibility for that by doing some random assignment, but it would have been nice to also have the pretest so that we can not just measure differences at the end, but differences in how much each group changed. So you might test your knowledge of the two-group post-test comparison and see if you can create one of your own. Now we'll look at the one-group pretest post-test. And so this is where there's no control group. You just have the experimental group, you test them before you do some sort of treatment, you give the intervention, and then you do the post-test. So imagine I gave each student in this class a test on the first day to see how much you knew about research methods. And then we went through a 7-week course, and I gave you the same test at the end. Would you do better? And so here we have a pretest. The treatment is really the course itself, and then a post-test. Why can't I just give each of you a test at the end to see how much you know? Well, the answer to that would be possibly you came into this course already really knowledgeable about research methods. And so I need the pretest to be able to measure how effective the course was, not just how much you know. And what are the limitations of giving everyone the same treatment? So there's no control group here. And the limitations associated with that are that I don't know if possibly over the course of 7 weeks, maybe everyone would improve their knowledge of research methods, and it really has nothing to do with going through the course itself. So it would have been really nice to have a control group that we can compare to, and then look at the post-test and say, look how great the experimental group did compared to the control group. And again, you might take this time to pause and create your own example. So next we're going to look at the two-group pretest post-test. So here we have some of the best elements of our first example, which is we have the experimental group and the control group. And we also have some of the best elements of our second example in that we have the pretest and post-test. So, sticking with the example from the previous slide, imagine there are 6 people in the class. Everyone comes on day 1 to take the pretest, but only half of the class stay for the 7-week course. The others go home to learn the material on their own. At the end of 7 weeks, everyone comes back for the post-test, and maybe we see, does the experimental group do better because they came to class each week and heard from the professor, or does the control group do better because, maybe coming to class was, a big waste of time, and maybe learning on their own was even better than sitting in the 4-hour lecture. So we would do that measurement at the end. So the thing that we can learn from this study that we couldn't learn from the other ones is that we can compare to the control group, which is really important. And it's really important that we have the pre and post so that we're not just seeing the end results, we can actually compare to before the intervention and measure change.